What's up, math scholars? Thanks for joining us for part 2 of our video review. I don't know if we'll be able to finish today, if we'll need a part 3, so stay tuned. I do have a joke to start the day. What's brown and sticky?
A stick.
A stick! Ha ha! Alright, let's go ahead and start number 12. Alright, number 12, I looked at it and I was thinking, let's try the old-fashioned factoring technique and see if we can factor this puppy down. And unfortunately, it doesn't quite work out because there's no numbers that multiply to 32 that would also add up to 8. Because your options are 32 and 1, 16 and 2, and 8 and 4. And none of those are going to work. So it's prime. Do you remember what happens if something's prime and unfactorable and you still need to solve it? Nope, I'm going to sing a song for you here at 7:53 a.m. Nope, the quadratic formula. So we're going to have our A value be 1, our B value be -8, and our C value be 32. That's how you have to solve anything that cannot be factored that is quadratic. That's that x squared and that x term. All right, I'm going to sing very slowly as we start putting numbers in, right? X equals the opposite of B plus or minus the square root of B squared minus 4AC all divided by 2. Wow, very good, scholarly singers. You all must be in the choir. I didn't even ask them to sing and they sang. Hey, it's probably time for me to tell you, I am going to include a few formulas on the exam on the very back page. So when you get the exam and you turn it to the back page, there'll be formulas such as quadratic formula, some of the different factoring formulas like the perfect squares, perfect cubes, well actually just perfect cubes, a list of the perfect squares, a list of the perfect cubes. So yeah, that's just kind of like my Christmas gift. So the quadratic formula's on there, so you don't have to put it on your formula. Alright, do you remember the term for this stuff? You're going to type that in first. The discriminant. So go ahead and type all that stuff in the bubble. I'll grab my calculator. Get it? Type in. I think so, but stay tuned because I don't remember. Squared minus 4 times 1 times 32. So that's the square root of -64. If you're in imaginary mode, you could actually go ahead and square root that number, and it'll square root for you if you're in imaginary mode. And we chatted yesterday about getting yourself in imaginary mode, I believe. So that's 8i. So we basically have 8 divided by 2 and 8i divided by 2. So 8 divided by 2 is 4, and 8i divided by 2 is 4i. Now that's our answer. Choose wisely, grasshopper. What are we choosing? Which one does look like is it? If this is my answer, what choice above corresponds? Yep, good job. Alright, they're asking for the maximum value. Now when they say value, that's a y value. I guess my advice to you would be probably to graph this one and then scroll up and down the table for the maximum y value that you find. It's always going to be the vertex because this is a parabola opening down. So let's just graph it and look for that vertex. Use a table to do that. So graphy graph, -x squared plus 12x minus 46. I'm actually just going to go straight to the table and I'm going to look at the graph. I'm looking for the biggest value in the y column. You can find that by scrolling. I think the largest value I could find was -10. So 6, -10 is that vertex. And so -10 is the maximum value. Does that make sense? You scroll up and down and look at those numbers and just look for the biggest number appearing in the y column. A rock is thrown from the top of a tall building. The distance in feet between the rock and the ground is modeled by this equation. So d is distance and t is time in seconds. How long after the rock is thrown? Is it 410 feet from the ground? So we always have this issue with word problems of, is that 410 going to be a distance, or is that 410 going to be a time? What do you think? 410 is going to be a distance. So we're going to put the 410 in for D. And I'm trying to think of what my advice would be on this one. I have written down on my paper that you can graph it and trace along the graph to kind of figure out when it's going to get to that point, but you might have to change your window. Or you can just solve it for t. And let's just go for the solve technique, because it's actually not all that bad to solve. So I would subtract my 410 over, because this is a quadratic that we're setting up. We've got 0 equals negative 16 t squared minus 4t. I think that'd be a plus 2, wouldn't it? Do you want to use quadratic formula to solve, or do you want to use factoring to solve? Factoring actually does work. Let's pull out a common monomial. What's a good common monomial you can think of? 2, very good. Leaving us with negative 8 t squared minus 2 plus 1. And now the stuff that we've got left is the... Did I forget something? Oh, I forgot the t. You know what I just thought of when I looked at what we just did? It'll probably be easier to factor what's remaining if this 8 is a positive. So let's factor out a negative 2 so that our 8 can be a positive. And that would make this 2 a positive, and that would make the 1 a negative. It just makes it, the box method works better when that leading coefficient is a positive, that leading 8t squared. And you can start using x's if you'd like, if your t's are messing with your mind. I hate using t's. They look like pluses to me. All right, so I'm going to box method what's left in the parentheses. We reviewed the box method twice yesterday, I believe. So we've got 8x squared in the upper left box. I'm just using x's instead. A negative 1 in the lower right box. Multiply them together and get negative 8. And what numbers multiplied to negative 8 that add up to 2? Let's go with a positive 4 and a negative 2, because we need to add up to a positive 2. Pulling out what they have in common, it'd be a 4x right here, making this an x, no, a 2x, and that'd make this a 1, and that'd make this a negative 1. So let me write what I've got in factored form right now. I've got that negative 2 out front, I've got the 4x minus 1, and the 2x plus 1. And our true goal was solve for x. So we're going to set that 4x minus 1 equal to 0, and we're going to set the 2x plus 1 equal to 0. We're going to solve both branches. This one ends up being a positive 1 over 4, because you'd add the 1 over and divide by 4. This one ends up being a negative 1/2. Now keep in mind, we were solving for time. This is seconds and seconds. You cannot have a negative time. I can't have my ball in the air, my rock in the air for negative 1/2 seconds. So you kind of trash that answer. And this is the only answer. It's 1/4 seconds. That was a fun little solving adventure. We had a little bit of everything in there. Box method, word problem. Whew. So Nathan was all concerned that we would have long division. The next one's synthetic substitution, which is just synthetic division kind of called. So that's actually fun. I really like that. Everybody okay on this one? A kid come teach it? Yeah. Sure. Does anybody want to teach for the video? Oh, did I just skip one? Oh, no. It's number 16. I'm sorry. I'm jumping ahead of myself. Here's number 15. Let's do 15, and somebody can do 16 if they'd like. So 15, it's the law of exponents. What happens when you have that 4 all the way out here and it's a little baby guy? He distributes to everybody. So it becomes 3 to the 4th. It becomes u to the 4th. It becomes v to the what? Do you remember whether we add or multiply? We multiply those. You would want to add them if it was this scenario, like this. But when it's parentheses, like we had there, it's multiplying. And then this is w to the 4th. So my final answer, I would want to calculate out 3 to the 4th. It's 81. 81, u to the 4th, v to the 20th, and w to the 4th.
Okay, class. So I set this up by putting the 4 in right here, and then you're going to take all of your coefficients, and you're going to line them up, and then you're going to do synthetic division. So first you're going to take this 8 down, and then multiply it by 4, which will be 28. Oh. Oh my gosh. 32. Okay, and then it'll be 28. Okay.
28 times 4, 112.
112.
You get when you add down?
I have no clue.
1 and 3. Then what?
Multiply that by 4.
4, 12. straight down.
403. No,
No, you're adding.
421.
Yeah. And then I always withdraw the double
Oh,
bar
yeah.
line. Circle it. So ask class which one they want to choose.
You want to choose A.
Very good.
Oh my-
Any questions? Please tell me.
So you're going to distribute the negative. And I'm sorry. And you're just going to subtract. Or add or whatever you need to do.
Yeah. Now, ask class, which choice should we choose?
Which choice should we pick? Nobody gonna answer me?
It's D. If you have any questions, Brian.
All right.
Wow.
Okay, so first off, you want to multiply the first. Oh Lord. Okay, that will be u third. You did the third. U third. Yeah, u third. This would be 2u squared, and then that would be negative 2u. Okay, and then you want to do negative 5u squared, and then negative 10u, and then 10. Then you want to, isn't that, yeah, okay. So that will be u to the third, and then would that be negative, negative 3u squared? Negative 3, oh, that, okay, I don't know what that is. Okay, and then that would be, two negatives, oh, that's negative 8u. And then, no, that's not it?
Negative 12.
Negative 12, okay.
You're pretty crazy. Okay.
That's my calculator. And then plus that. Right.
Now, ask the class, what answer should we choose?
What answer should we choose? Yeah.
Taylor says A.
A.
Very good.
Any questions?
Go.
All right, I'm gonna improv this, guys. So let's go. So first, you have to plug this in.
Wait, no.
No.
You just want a 4 right there. It's the solution to this binomial.
Oh.
Whenever you're dividing a cute little binomial, you'll put that solution in the box.
My
Good,
bad.
Keep going.
I forgot this is synthetic. So then you place in a 4, negative 12, negative
Yeah, 0, because there's no squares.
There's no squared term. He's putting a 0 next.
a 0,
Idea.
a negative 48, and a negative 60. Then you drop down the 4. I'm gonna need some help with calculations. I can do that. Then you add these together and you get 4.
16.
16 again.
Oh, it's 15 times 4.
4. We're going with 64.
You're doing it by time, supposed to.
He's fine. He's fine. I'm back at it.
We get 4. Then
So now he's got his quotient, which is 4, 4, 16, 16, but he's got a remainder of 4. And they always take that remainder and they put the remainder over the divisor. So it's either going to be D or B. I'll let you choose.
let me think this through.
4, 4, 16, 16.
It's D.
Oh, yeah.
Yep.
There we go.
And they've got the remainder over the divisor. Thank you.
D.
All right, so this time they're saying find all the zeros. The best way to do that is using the 0 button in the calculator. So we're going to hit our y equals to get our graph put in. I'll move this over. So 10 x to the 4th. Move your cursor so it's big again. Plus x to the 3rd. Move your cursor so it's big again. Minus 12x squared. Minus x plus 2. Make sure I enter that right. I'm going to click graph just to see what we're dealing with. My Zoom is crazy. What should I do, everyone?
Zoom 6.
Yeah, Zoom 6.
Whoa, that's crazy.
Now, my first stop is normally the table to see if any of these zeros are at actual integer locations. So I think 2 of them will be, which is kind of nice. Right here I've got a 0 at -1, and I've got a 0 at 1. But you can tell from my picture, there's actually 4 places that it's touching. So I'm going to have to use the second trace menu, the second calculate menu, to get those other 2 locations. Do you remember doing that stuff, left bound, right bound, and all that jazz? You could zoom in once, that might help your case. Zoom in and then hit enter, and you'll be able to see it a little bit closer up. But we figured out -1, we figured out +1, it's these 2 we need to get. So I'm going to do second calc 2, because we're finding zeros. What does that point to the left of this point my finger is looking at right there? I would go with, like, if that's -1, I would go with, like, -0.8 or something like that. -0.8. It's weird to have a decimal left bound, but it's okay. A good right bound would be 0. That'd be fine. Enter one last time, now that my arrows are pointing in, and I got it. It's -0.5, or -1/2. Which I guess that would have showed up on the table if our table set up had included decimals. Let's do the same thing to find this one over here. They might be reflection images, they might not. We'll find out shortly. Second calc 2. A good right bound for this one would probably be 0 again. And I'm going to use a 0.8 as my left bound, just because it's kind of like not quite all the way to 1. One last guess? 0.4, so they were not mirror images of each other. There's your 4 zeros. Alright, we're moving on to P's and Q's. Our P list is all the factors that would divide 9, so 1, 3, and 9. Our Q list is all the factors that would divide 1, so 1. And then it's every possible positive or negative P over Q, so 1 over 1, 3 over 1, and 9 over 1. What choice should we select, scholars? D. I think we'll get close to finishing, but not quite finished. That's my guess. 22. Use the graph. You think? Use the graph to approximate all the real zeros. So the zeros are here, here, and here. So -1, -3, and -5. That's what I'm seeing. What choice should we select, scholars? That one was easy. Which is equivalent, I would definitely type this in my calculator, 16 caret -1 divided by 4. That's how I would type it in. I don't necessarily use any fancy buttons when I type that. And at the end, you can hit math enter if your answer is a decimal. What is your answer? It's B? No, 1/2. Almost 1/2. Alright, 24, just like yesterday, you could probably type this in and see which one is equivalent of a decimal, but I'm going to show you how to do the math way, because, I mean, I'm your math teacher, it's kind of my job. So, this is when we're adding radicals, we did this very recently in chapter 3, the end of chapter 3. You need to have like terms, you need to have like apples, I called it like apples. These are not alike, so I'm going to use perfect squares to kind of simplify them down. Can you help me break 32 down so that one of the numbers is a perfect square? Forgot all your perfect squares? 16 and 2, and the square root of 16 is 4, so that's how that one would be written in simplified form. We'll do the same thing with the 50. Let's break it down so that 1 is a perfect square. Can you think of a perfect square that would break down 50? 25 and 2. And the square root of 25 is 5, so that's what that would look like in simplified form. Now we have like terms. If you have 4 apples, and you add on 5 apples, how many apples do you have? 9 apples. 9 apples. Do the same thing on 25, but this time look for a perfect cube. So we want to break 48 down so that 1 is a perfect cube. Can you think of someone on your perfect cube list? Do you remember the perfect cube list? The perfect cubes were 1, 8, 27, 4 times 4 times 4, 64. Do you think any of those numbers will break down 48? 8. So it's going to be the cube root of 8 times the cube root of 6. Yeah, and the cube root of 8 equals 2. My birthday's shaking. It's so crazy. It's 2 cube root of 6. Yep, we'll make a push to finish. Let h of x be 3x squared. Find h of negative 2. Do you remember how to do this? It was very recent, chapter 3. It's all the chapter 3 stuff. So you're going to start with h of negative 2. So you're going to take a negative 2 and put it in for x. That's just going to be step 1. Order of operations would square that first, which is 4, and 3 times 4 is 12. Everybody's still on board that 12 is the first part of the answer? But then you still have this other h, so now you have to find h of 12. So what we had just found was h of negative 2, but now we have to find h of 12. So we're going to put a 12 in for x. So it's going to be 12 squared, which is 144, times 3. So that is 432.
Did the kids like their hot chocolate party yet?
Oh my gosh, they loved it. We gotta keep going though. We want to finish. 27? Alright, so here's where we're at. We're doing f of g of x. F of g of x. So you're going to take the whole entire function g of x. You're going to circle it. And you're going to put it in right about here. Now this sometimes results in a foiling problem. In this case, not so much. Because it's just squaring one single term. So here's our setup. Negative 2x squared minus 1. Alright, so you're going to take the negative 2 and square it, which will turn to a positive 4. And you're going to take the x squared and square it, which is going to be x to the 4. So that's where we're at. What answer should we choose? B, yep. Oh, we got this. We have 3 more problems in 10 minutes. Alright, we got this. I was getting nervous. 28, which gives the solutions of... Oh gosh, so this didn't copy onto my paper. Did it copy onto your paper? That this cube root should go all the way? Okay,
Yeah.
I don't know why it didn't capture that way on my board. Well, how should we start this? What should we do to both sides? Cube, just cube both sides, because the cube will cancel the cube root. 6 to the third, 6 times 6 times 6 is 216. And then we're just going to add our 30. So there's only going to be one answer. They're trying to trick you into thinking there's 2 answers. The only time you have 2 answers is if you square root something or fourth root something. This stuff is easy because I feel like we literally just did it last week, at least to me. We got our velocity problem. I actually think this was on the last test, where V is velocity of the sound and T is the temperature in degrees Celsius. Do you remember this one from the test? Does the 340 go in for velocity or temperature? Velocity. Yeah, this was on our very, very last quiz test or whatever we have. And I'm going to use an X because, again, I don't like my T's. I think they're plus signs. What should we do first? Or what do you think we should do first?
Divide by 20.
Divide both sides by 20. Good, he remembers. I have written down that that's 17, but you can check with the calculator if you want. What do you think we should do next? Square both sides. That'll cancel out your square root. 17 squared is 289. And what do you think we should do last? Subtract over your 273. 16? Is that a choice? Heck yeah, B. I hate when I get my answer, I look up and it's not a choice. I panic. Yesterday. Alright, we got this. Awesome, I'm so happy. Last one, number 30. If we did go too fast after I finish the video, we can go back and look at something we might have blown right by when you had a question still. What gives the solutions? All right, you know what you could do on a multiple choice test? plug in all these answers and see what works. Absolutely, plug it and check it. But I'm just going to solve it from scratch because that's what math teachers do again. I'm going to square both sides first. That'll give me x plus 12 equals x squared. This is one of those quadratics where we have an x squared term and an x term, so we're going to get it all on one side together. I'm going to subtract the x over to the right. I'm going to subtract the 12 over to the right. And finish it off with some old-fashioned factoring techniques. So I'm looking for numbers that multiply to negative 12 that would add up to a negative 1. Can you think of them? Negative 4, positive 3. So that makes our answer 4 and negative 3. Now, you should definitely check these. If you would go to put your 4 in for x, it'd be the square root of 16 equaling 4. That'd be fine. But if you go to put your negative 3 in for x, it'd be the square root of 9 equaling negative 3, and you can't have that happening. So that's one of those extraneous solutions we used to chat about. We're just going to go with the 4. Hey, thanks for joining me for the video. Hope to see you at a study party.